Hey guys, welcome back to another lesson. This is part 2 of rational zero theorem or rational root theorem. Zeros and roots, they could be interexchanged, right? Same concept. The first lesson was just knowing what the theorem was and how to use it. And then we used it to figure out the volume dimensions for a rectangular solid, okay? And as you can tell from that example, well, there were some things going on there where we used the rule of signs to clarify some things. We used a little bit of synthetic substitution to see which one of those worked. I even include the discriminant from quadratic formula. A lot of different elements there. And that's what you're going to see in these problems, where there's not like a step-by-step process to solving it. It's pretty much use previous tools that you discussed and learned in previous lessons and see which ones are going to be beneficial to you today. Now, in this part 2, I'm going to do 2 problems that are more run-of-the-mill type things that you're going to see, but at least you can kind of get a more, familiarity with it, all right? So what we're going to do, here's the first polynomial. I'm going to find all the zeros for this polynomial. So to do that, I'm going to find all the possible ones first, okay, using the rational zero theorem. So P is 30, it's always the constant, and Q is always the leading coefficient. Be careful. If this is not written in descending order, you can get in some trouble here, okay? So if x to the 4th was mixed in here, and you just took whatever it was as the first term in this polynomial, you're not getting the right value. So always make sure, is this written in descending order? Yes, I can go ahead and find those values. Now, the corollary that we talked about yesterday says, hey, wait a minute. If Q's 1, then all my possible zeros are factors of P. Okay, perfect. So I don't have to worry about, adding more factors. So factors of 30 would be 1, 2, 3, 5, 6, and 15, including the negatives, right? That's why we have a positive negative sign next to each one. So these guys right here are all possible zeros, which is another word for solutions to this guy. So in other words, what makes this 0 when I plug those numbers in? Which one of these numbers makes that 0? Okay. Now, I made the idea to you that if you had a graphing calculator, you could type this in, use the table function, and see which one of these gives you that 0. No issue with that. Today, I want to show you how you can go about it differently if you didn't have that tool with you, okay? And to be honest with you, the graphing calculator will not come up with imaginary values for you as well. So this is a good lesson to listen to watch, okay? So what I'm going to do is I'm going to use synthetic substitution to see which one of these works. And remember, if I'm using synthetic substitution, this is very important, I want the remainder to be 0. Because if the remainder is 0, oops, sorry. That was a weird cutaway from the video, but my school was making announcements. I didn't want names to be in the video. Okay. So we want the factor to be 0. Okay. That means that it is 0 to the actual problem itself. So using synthetic substitution, here I go. This would be 1, 2, 2, negative 17, negative 17, negative 6, negative 6, and then 24. I know I went through that rather quickly, but we've done synthetic substitution and division in previous videos. So is my remainder 0? It's not. So 1, not a solution to this guy. All right, let's continue. Let's try 2. Let's see if 2 would work. We could get lucky, guys. We could. I'm hoping. Multiply, I get 2. Add, we get 3. 6. Negative 13. Negative 26. Negative 15. Negative 30. And 0. Hooray! It works, okay? So, looking at this, yeah, we're still recording, sorry. Looking at this, it's 0. That means 2 is a solution. Awesome, we got something. How many total solutions will this guy have? Look at the leading term. The degree of this guy is what, 4? There's 4 answers. I need 3 more to go. Ugh. I could use rule of signs to figure out the possible types of solutions, but I'm going to skip that this time. I'm just going to keep going with this. What I have left here is x cubed plus 3x squared minus 13x minus 15. Now, given this, can I solve this for the other answers? Not really. I couldn't factor by grouping because there's nothing in common for me to group these guys with. So what do? Well, continue dividing. This, whatever the solutions are to this guy, will still satisfy the original, right? So continue plugging these possible zeros into here. And that just means we're going to continue to synthetically divide, okay? So let's try 3. Let's just keep going down the possible solutions. And I'm going to use these coefficients here. So it's going to be 1, 3, negative 13, negative 15. Okay? So let's see. Multiply, we get 3, add 6, 18, 5, 15, 0. Ha-ha! We got lucky twice. So, is 3 a solution? You bet it is. Okay. Now, what do I have left? It's x squared plus 6x plus 5. Okay. This, I can solve, right? This I couldn't. But if I solve this guy for the other 2 zeros, I'm done. I don't have to keep using synthetic division. Okay? So, set this equal to 0. Factors of 5 that give me 6, 5 and 1. Just like that. Okay. Set each one equal to 0. I get x to be negative 1 and negative 5. There we go. Those are my solutions. Now notice something. I want to make a couple announcements with this. Negative 1, negative 5, they were in my list of possible zeros. But see how my synthetic division, I was just doing the positives first? It would have taken me a while to get to the negatives, right? That's why I suggested let's just solve the rest of it right now, okay? All right, 2, could we use rule of signs to figure out that there were 2 positive and 2 negative? Yes. Considering the nature of this problem, I didn't think it was necessary to really know that information ahead of time. But you might want to know that information ahead of time, and that's okay, okay? So that's it. Those are my answers for that guy. Pretty cool, huh? Okay, we'll do one more. Come on, one more. This is fun, isn't it? Let's do one more, okay? Same thing, we're gonna find all the zeros for this function. There we go. Okay, so the p-value is 45, that's the constant. The q value is 1, the leading degree. Now, this will have 4 answers too, right? Because the degree is 4. And hey, q's 1. Yes, finally. Well, not finally, we had the last problem like that, but that's nice. That means that my possible zeros is just the p factors. So factors of 45, here we go. Let's see, not 2, but 3 works. 5 works. 9 works. 15 works. And then 45. Okay. All right, so we got these guys to work with. Now, could we type this in a calculator and see which one of these actually gives me a 0? Yeah, we could do that. That'd be cheating, though. The calculator has enough fun. Let's have some fun ourselves. Let's try this out. We're going to try 1. That's what we're going to start with. Let's see if 1 works. And we could get lucky. So here we go. 1, 4, negative 14, negative 36, 45. All right, here we go. Let's go ahead and divide this out. So multiply, we add, multiply, add, multiply, add, multiply, add. Hooray! One worked. Who would have thought it? Maybe this guy. But one is a solution. Okay, so x equals 1 would work. I still have 3 more to look for. Now, what I'm going to do, let me write out this depressed polynomial just to see what it looks like. See, it's x cubed plus a 5x minus 9, oh, sorry, squared, minus 9x minus 45. All right. Now, we could continue to divide, or we could try and solve this guy for the remaining part. I'm going to solve this. I think we can solve this. I'm going to set this equal to 0, and I'm going to group these guys. I'm going to solve by grouping. The first GCF would be an x squared, so I'm left with x plus 5. The second GCF would be minus 9, so it'd be x plus 5. Oh, this is good. Good things are happening, guys. We get the same value. So now we get x squared minus 9, minus 9, as one of those factors. X plus 5 is the other one. Okay? Now what I'm going to do is solve each one by setting them equal to 0. So for the first one, x squared minus 9 equals 0. We'll add the 9 over to the other side. And then when I take the square root, I get positive negative 3. This is looking good. Over here, if I set this equal to 0, x would be negative 5. All right, so we have plus or minus 3 and 5. So out of this entire list, those 4 answers will make this guy 0. Those are my solutions, which is also, ironically, the x-intercepts, right? That's where it's going to hit the x-axis at. So these are the intercepts, the solutions, okay, the turning points, possibly, depending on how the graph looks, but we're not going to get into every single detail because this is just the start of it, right? Everything we talked about in this chapter, we can now include to fully graph this accurately and describe it accurately, okay? Now, once again, you can use the graph and calculate and the table function to figure out which one of these works, but I would highly recommend use that as a way to check your answers, okay? If you want to go through the table and say, oh, one works, okay, still use synthetic substitution to show me that it works, okay? Now, this guy right here, we could have still divided. In fact, I'll tell you what. Let me just show you real quick. So let's plug 3 in. Okay, so we have 1, 5, negative 9, negative 45. So we're still going to get the same answer, but let's see. Plug 1 down. So we get 3, 8, 24, negative 15. Positive 15. And then 45, 0. Okay. So 3, positive 3 is a solution. We got that. We have x would be squared plus 8x plus 15. Now, I can continue to divide, or I could solve this one, which would be x plus 3, x plus 5 equals 0. I'll solve this one by factoring. I get x to be negative 3, x to be negative 5, which, hey, that's what this guy is, right? Okay. Oh, negative 5. I'm sorry. Were you guys screaming at the camera right now? It's negative 5 here, but I didn't write negative 5 up there. I'm sorry. Okay. So once again, we get to the answer the same way. It just depends. Online, you'll see my notes with different things worked out. I have different suggestions to figure out things. You don't have to use all my suggestions. You really don't have to. It just depends on what you feel comfortable with and what tools you want to use. Same thing with the homework. When you look at my answer key, I make a lot of different suggestions. I think I do prime factorization for one of them, just to find all the factors of one of the values. So once again, it's in your court as to how you want to solve it. And don't be afraid to contact me. I'd be glad to help you with it. All right. Hope you're doing well. And until next time, guys, I will see you in the next lesson video. Take care.